Hi, my name is Colin. The two main branches of calculus are differential calculus, which concerns rates of change and slopes of curves, and integral calculus, which concerns the accumulation of quantities and areas under and between curves. These two branches are related to each other by what's called the fundamental theorem of calculus, which, roughly speaking, states that differentiation and integration are opposite processes. Talking about integration, one of the first things you need to grasp are the two different types of integrals. The first type of integral is called a definite integral. Consider the following definite integral of the function y equals 2x, which is being integrated with respect to the variable x, from x equals minus 1 to x equals 3. Now, recall from classes that a definite integral is ultimately a number which has a close relationship with the notion of the area under a curve. Specifically, this integral here represents the signed area under the curve y equals 2x from x equals minus 1 to x equals 3. The phrase signed area, in contrast to the absolute area, refers to the fact that the integral will return any area underneath the x-axis with a negative sign. Definite integrals will be covered in more detail in separate modules. In this module, we're going to focus on the other type of integral, which are called indefinite integrals. Consider the following indefinite integral of the function y equals 2x with respect to the variable x. Observe that in terms of notation, the difference between a definite and an indefinite integral is that definite integrals have these numbers here, which are called limits. While indefinite integrals do not. Also, with any integral, the function that we're integrating is called the integrand. Now, importantly, recall from classes that an indefinite integral is ultimately a family of functions. Here, this integral represents the set of all the antiderivatives for the function y equals 2x. In other words, it is the set of every single function whose derivative is 2x. That is, every function whose slope is given by the function 2x. One such function is the simple quadratic y equals x squared. Indeed, you know that if you differentiate x squared, you certainly get 2x. Now, a crucial observation is that if you shift a function up and down, it doesn't change its slope. Indeed, if I grab the parabola y equals x squared and move it up or down, which is achieved by adding a constant to the function, observe that its slope at any x value remains exactly the same. This means that the family of functions given by y is equal to x squared plus any constant all share the same derivative of 2x. And conversely, it turns out that any function with a derivative 2x must come in this form. Thus, this family of functions is precisely our indefinite integral. The arbitrary constant c is called the constant of integration. And should always be attached when you evaluate an indefinite integral. Otherwise, you will not obtain the most general antiderivative. Moving on. Recall that polynomial functions were the first types of functions you learned how to differentiate. These included constants, linear functions, quadratics, and cubics. Now let's learn how to integrate a simple polynomial. Specifically, let's calculate the indefinite integral of the quadratic function x squared minus 4x plus 5. That is, we wish to find the set of all the functions whose derivative is given by x squared minus 4x plus 5. Now, if you recall back to the very first time you learned how to differentiate a simple polynomial, you would have hopefully done it fairly slowly and methodically by identifying all the relevant rules used. Here, we're going to do the same and list out all the steps possible. And with more practice over time, just like with differentiation, you'll be able to perform similar integrals much quicker and with less steps. Now, in terms of overall strategy, roughly speaking, differentiating polynomials entails differentiating a bunch of power functions using the power rule. Here, with integration, we're going to employ a similar strategy, and we'll end up integrating a bunch of power functions. Alright, the first rule we're going to use is sometimes referred to as a linearity principle. Now, roughly speaking, this linearity principle says that to integrate this quadratic function, we're allowed to integrate each term separately. Very similar to when you differentiate a bunch of functions added together, you can simply differentiate term by term. Anyway, here, this means we get the following. This linearity principle is very useful as it allows us to break up the integral of a large function into a chain of smaller, more manageable integrals. Now, this middle integral can be simplified using another useful linearity principle. This principle effectively allows us to pluck the constant -4 to outside of the integral, which will give us the following. Notice that now we've broken up our original integral into 3 smaller integrals. And in all 3, we're integrating either power functions or a constant. Now, to integrate power functions, we use a rule that's not too dissimilar to the power rule for differentiation. Recall that the derivative of a power function involved bringing down the power and then subtracting 1 from it. Here, the integral of a power function, x to the n, involves first adding 1 to the power, and then dividing by this new power. As a procedure, this is exactly the opposite of the power rule for differentiation. So here, to integrate the power function x squared, we first add 1 to the power to give us x cubed, and then we divide by this new power to give us x cubed on 3. And similarly, to integrate x, which really is just x to the power of 1, we get x squared on 2. Now, let's move on to our last integral. To integrate a constant a, with respect to the variable x, we simply get the constant times the variable. This should come as no surprise. since the derivative of a constant times x is just a constant. Thus, the integral of 5 is just 5x. Thus, our total answer so far is the following. Finally, although we have technically evaluated 3 indefinite integrals here, which should really give us 3 independent constants of integration, these constants can be combined, and so by convention we only need to write down just one constant of integration, c. Thus, simplifying, our indefinite integral is just x cubed on 3 minus 2x squared plus 5x plus our constant of integration c. Now once again, we've listed all the steps here. The procedure in practice, however, is much quicker. By the time you've had enough practice, you'll probably be evaluating this integral in a way similar to this. Well, you know we integrate term by term, predominantly using the power rule. So for the first term x squared, we just get x cubed on 3, while the second term is going to give us 4x squared on 2, which really is just 2x squared. And finally, 5 integrates to just 5x. And we also need a constant of integration. In the meantime, however, to become well acquainted to the rules of integration, it's a good idea to slow things down to understand how all the rules are used properly. Alright, I hope you enjoyed that. See you next time.